Great, so hi, I'm Louis. I'm very happy to be in Barcelona because I kind of have a special relationship with this city. It's here that I launched my book, which is called Bootstrapping Machine Learning. For some reason, I did it in Barcelona. So there's this, and then, as Mehdi said, there's APIdays, which is a series of conferences. The first one took place in, well, it's written on the t-shirts, Barcelona. So that was last year in November. And yeah, why APIdays? So I guess the first reason is probably this song. We thought it was cool to call it, APIdays. And then at some point, someone in the team sort of realized that, hey, APIdays can also mean predictive APIs. So we decided we'd stick with that name. But yeah, predictive APIs. So I'm going to tell you a little bit about that, and also, so people would use predictive APIs to build predictive apps, right? And the thing is, if you have a look at what people are saying about predictive apps, let me move the pointer away. It seems to be pretty big. I mean, there's this Forrester guy who predicts that it's going to be the next big thing. There's this guy I think he's the chief data scientist at Visa, the credit card company, who talks about predictive as, the killer app for big data. Everyone speaks about big data, but what should we do with all this data? And yeah, to create predictive apps, we need two things. We need machine learning, so I'm going to explain a little bit about that, and then we need data. There's one problem, though, which is that according to McKinsey, I don't know if you're familiar with the big data study from 2011 by McKinsey. Essentially, it says that we're going to need more and more expertise in machine learning, but there's not enough people who know about it, who know how to use it. So there's a shortage of talent. There's going to be a shortage of talent for the upcoming years. So that's the sort of only limitation. And what's interesting to see, so how many people are familiar with Microsoft Azure machine learning, the Azure ML product? Yeah. So it's brought a lot of attention to this new wave of services now making it easier to do machine learning so that you don't have this problem of finding people who have PhDs in machine learning to actually use it and create value from your data, create predictive apps. So there's Azure ML that brought a lot of attention to this new wave of tools, and there's also Amazon machine learning, which launched last month. And they're quite different, but still, it's bringing, their vision is to make it much easier to do machine learning, and they're bringing a lot of attention to the possibilities that are now being offered. So what the hell is machine learning, right? We've been speaking about that for 2 minutes and still haven't introduced it. So let's take an example that shows how frequently I update my slides, which is an email I got in 2013. And I didn't see this email. I had to dig into my spam folder actually to find it. And yeah, luckily for us, we've got spam detectors. That's not very new, but that's machine learning. So you've been using machine learning for a very long time. Great news. And what we're doing here is that we're asking a question about this email object. We're wondering what type of email is this? Is it spam or is it ham, like regular email? So that type of problem where you ask a question that can be answered by fixed set of a fixed number of possible answers. So here, spam and ham. It's a classification problem. There's two classes. There's spam and there's ham. And we will speak of the email as the input, and the answer to that question, so spam or ham, is what we call the output, right? And the way that machine learning works is that it takes a set of example data. So we've got emails, it's the I object, and we've got outputs, so we know if they were spam or ham. And then based on all that data, somehow we learn. The machine learns. It creates what we call a model, which is going to explain the sort of relationships between input and output. So that when you get a new input, you use the new input with the model, and that creates a prediction for what the output should be. So when you get a new email that you'd never seen before, you can say before the person actually looks at it whether it's spam or not spam, and then if it's spam, it goes to the spam folder. So it seems, conceptually it's very simple, but the problem is that to make it work, you need to have examples of both inputs and outputs, which means that in this particular case, you need examples of emails and you need the answer. Like you need to know whether in these examples you have spam or ham. So you have to have someone at some point that's going to spend time to label these inputs and say, yeah, that's spam, that's a regular email, and so on for a set of examples. And the thing also is that you need to have enough examples, otherwise when new inputs come in, if you don't have enough examples, you're not going to be able to refer to your example inputs, because there's this chance that you get a new input which is very different from all the inputs that you had in your examples. So if you get more and more examples, then there's less chance that you get stuff that's really new. Right. So we've got data, input, outputs, we train a model, we use that model to make predictions on new inputs. How do we get that model, right? Because that's the whole point, getting the model, and then we're happy we can create this spam detector, or we can create our predictive app. So that's where predictive APIs come into play. And predictive APIs, the really cool thing about it is that they allow developers who are not familiar with machine learning to create predictive apps. They just have to call a very simple API, and then they can build this new awesome feature that has intelligence in it. So that's sort of the promise. Like I said, there's two phases in machine learning. There's train and predict. So you train a model and you predict with a model. And as a consequence of that, there's two core methods in predictive APIs. One that allows you to train a model, and one that allows you to predict with a model. So it kind of looks like this. You've got this create model method that takes in a data set. So that can be a CSV file, for instance. And based on this model object that it's created, you can use this other method, which is create prediction, where you give the ID of the model and you give a new input. So in my example, a new email, and you get the outputs. You get the predicted output, sorry. And that's actual code using a predictive API, which is big MLs. And as you can see, it's very short. And this is doing like machine learning in, 10 lines. There's this training data.csv file that has all the data in it. And that's, if you didn't have this, it wouldn't work. Obviously, you need data to learn from. And then, the quality of the model that you create is down to the quality of the data, because that's the only thing that you have influence on. Like you can change the data, but the rest, it just creates a model. So I think that bit of code shows how important it is to provide good training data. In the email example, in detecting spam, you could also think of another problem, which is detecting important emails. So that's what Google does, and they do that in their inbox. Google Inbox clients, and then there's this, it's called priority detection. Sorry, it took me a while to remember. Priority detection, it detects the important emails and it puts it at the top of the list. And it's also a classification problem. You get a new email, you want to say whether it's important or not. And it's not just the text of the email that's going to be important, it's also all the information about the person who sent it. Like, is it someone with whom you correspond a lot? Do you usually respond quickly to their emails, or do you usually not respond to those emails because you don't care so much? So you've got to take into account the actual text data, but also you have to think about everything that could be of interest, that could have an importance on the output. Detecting whether an email is spam or important, that also depends on the actual content, but also the person who sends it. So if you can also capture this information in your training data, then you're likely to get a better model. All right, so these predictive APIs, that's opening up machine learning for all, democratizing machine learning, and that's why I'm here. The thing is that there's different predictive APIs, and it depends on your needs which one you're going to have to use. So I'm going to try to help you navigate in that space. And I've listed them in increasing degree of abstraction. So let me just go through them. I'm not going to go over the algorithmic APIs because basically it's just APIs that give you access to a machine learning algorithm, so you have to know which algorithm you want to use and with which parameters, so that's not interesting for this talk. I'll start with what I call the generic predictive APIs. So you could tackle, with these APIs, you could tackle pretty much any machine learning problem. Like for instance, you want to say whether an email is important to a particular user. So importance for me is not going to be the same as for you, because we don't have the same interests and we don't correspond with the same people. So you can learn a custom model. You put data that's custom to the end user, and you build a custom model of importance. And you can do that with these APIs. So it's pretty much what I showed with the BigML example, except that there's not only BigML that can do that. So you've got Google Prediction API, BigML. There's a company in France which is called Predictive. There's Wolfram with their new cloud offering, and then lastly there's Amazon. Like I said, they released this Amazon machine learning product a month ago, so they fall into that category. And if you want to have a look at a little comparison, so I made this and it's on my blog, so the link is here, but if you just go to my name, louisdorard.com/blog, you'll find it. I made a little comparison in terms of performance of these different APIs, and there's three things so there's 4 APIs that I compared. There's 3 things that I had a look at, which is, first of all, the accuracy of the model. So I won't go into which data set I used and which accuracy measure I used, but the higher the better, and then it can go up to 1. So Amazon had a very accurate model, and then Predictive was quite good, and then BigML, and the last was Google, which was not that accurate. You also had, there's my time over, no? There's 2 other aspects that are important. Is how long it takes for the training of the model to complete, and also for making predictions. So that's what I call test time. That's making predictions. So in this particular case, the training was done over, I think, 100,000 data points, and test was on 5,000, something like that. So that I measured the training time, and again, results are in seconds, and actually Amazon is not that good anymore. It was very accurate, but if you look at how long it took, it was quite slow. And in the end, the quickest was BigML. So that's something that you might want to take into consideration when choosing one of these services. How long it takes for both methods, training and making predictions, and how accurate the model is. This comparison I made is just for one data set, so you might get different results with your own data, and the only way to find out which one is the best is just to try them all. Okay, so then there's generic for text, which is kind of like the same kind of APIs, except that the only inputs you can work with are text. Like, you have text from a document, and let's say that you want to classify documents in your company. You want to say, you want to add a tag to each document to say which project they relate to. So there's project A, B, C, and then you label some documents manually, and then you can also once you've done that, you can use it to create a custom model which is going to classify new documents. It automatically detects which project it's related to, and but yeah, the input is just going to be text. There's a few of them. I think that you classify as I'm not sure it's still up, but I think that the one you should have a look at first would be Monkey Learn. It's very recent. They launched at TechCrunch, I think, a year ago, something like that, and it looks very promising. And then there's problem-specific APIs. So you're still going to be able to provide your own data, build your own model, but that's going to be for one particular type of problem. I'll take an example: detecting churn. So customers who are not renewing their subscriptions. So the question is this customer going to leave next month? You answer by yes or no. But that's one particular type of problem. You're expecting data that looks like customer data, and you're hopefully there's more customers who stay than customers who leave. So you can you can exploit some particular knowledge about that type of problem into the model building. I mean, I'm saying it's more the API provider. So it can provide you with a model that's better suited to your particular needs. And another example is detecting fraud. So is this transaction fraudulent? And hopefully, by nature, fraud is something that's quite rare, hopefully. So, that's knowledge that you can build into that the API provider can build into his service to create better models that are more suited to this particular task. So it exploits the fact that it's expecting that fraud is going to be rather rare. And another thing which I didn't say is that in some particular cases, like churn detection, you might provide some information about your customers, and then the provider would be able to enrich this data with if you have if you have an email address and they're able to find data that's publicly available from social networks, it will use that as well. So they also have some data enrichment features. So there's Churn Spotter, Frame.io, Churn Spotter. They just launched at TechCrunch on Monday. TechCrunch Disrupt in New York. So yeah, definitely check them out. And then fraud detection, there's Sift Science, lead scoring. I won't explain the personal assistant thing, but if you want, you can ask me more, either if we have time for questions, or you can ask me more in the conference hall. And then there's the fixed model APIs. So fixed model APIs, that's the simplest to use. The model already exists. Someone has already trained a model based on data that they have collected, and you can reuse that model. So that works for sentiment analysis. Like, for instance, you have a tweet that mentions your company or your brand, and you want to be able to say whether it's positive, neutral, or negative, and you want to do that for all the tweets that mention your brand so that you can sort of measure how things are going. And you don't need to build your own model for sentiment analysis. Sentiment analysis for me is the same as for you. So we can just reuse models. And it's the same thing for spam. We can reuse spam detectors from one company to the other. So that's why people built models and made them reusable. And for fixed model predictive APIs, since you're not building the model, there's just one method, which is querying a prediction. So you just send, for instance, you just send the text of the email, and it says whether it's spam or not. For text, you've got Datumbox. There's Semantria. I haven't used it in a while, but yeah, it does similar things. So it analyzes text. It's going to say, for instance, which topic, which is the topic of a document. If it's I don't know, sports, politics, whatever. They've got all sorts of models. I'll just let you check them out. There's Indico for vision, and Alchemy API, which was recently acquired by IBM. And what they have is an API to which you can just feed images, and it will detect the things that are in these images. Like if, for instance, there's a cat, it's going to add a label cat to the image, and it detects persons, objects. I think it can also detect actions like, like the person is running, for instance, or that sort of thing. But you'd have to check that last thing. I know that Google does that definitely, but I have a doubt for Alchemy API. Okay, so that was the list in increasing degree of abstraction, but you can also think of it as, increasing degree of customization. Like the fixed model, it's the same for everyone, and then generic, you can provide your own data, and algorithmic, you can also use your own algorithm. So what if you want to use your own machine learning algorithm because in your company there are data scientists, they're building models, but it kind of stays on their laptops, and you want to use it on for the whole company, for the service you're providing. What if you want to use your own data processing algorithm, not just machine learning? So I'm going to talk briefly about appification. How do you turn your data processing into an API? That's the problem that the Microsoft Azure people refer to as the last mile problem. You've created a model that works on your laptop. I mean, a data scientist has created a model, and they've done stuff in R or Python, and it works on their laptop. But then, how do you take that into production? How do you make it available to all the end users? How do you deploy that to your servers? And that's the last mile problem, and actually it's a tough one. So that's what the Microsoft people decided to tackle, and they created this Microsoft Azure machine learning product, which is sort of so the interface is a canvas where you can connect different blocks, so you can't see it that well, but this is a block, and it does some data processing, and then at the end of the processing, you connect it to another block that does another step, and then you define a pipeline like that. And once you've done that, so that could be, process the data, remove one column, or expand, add more information, or whatever. It could be, run the machine learning algorithm. Anyways, what happens is that you have data in input, and then in the end you get an output. And once you've defined that pipeline with Azure ML, then you can create it into, you can click on this Publish Web Service button, so you create an API like this. And in terms of scalability, because you're going to be interested in scaling out your system, so that when there's more and more people coming to your service, you can still provide a good quality. This product has this auto scaling feature, so arguably it's going to scale out automatically. But yeah, that's something to consider. How do you make things scale? And that's the reason why it's that difficult to to take a machine learning model that's being created on a laptop and to put it into production. If you'd want to create the same thing with open source software, so you should probably have a look at this framework, which is called Spark, which sort of takes care for you. It takes care of parallelizing the data processing, and so that you just have to choose which algorithms you want to use and how you want to process the data. There's a library in Spark which is called MLlib for machine learning library. So some algorithms you can just use out of the box. And the cool thing is that Spark is going to take care of parallelizing things, so that when you need more resources, when you want to scale out, well, hopefully you can just add nodes to your Spark installation, and it's going to have more storage and more computing power, and the Spark frameworks handles everything for making it parallel and helping you scale out. This is Prediction.io. Prediction.io is a something that they call an open source prediction server. So it's based on Spark, and what it does, it answers this problem of how do I turn my model or my data processing into something that's scalable and that's presented as an API. So another way to think about it is to say that Spark plus Prediction.io gives you a predictive API. Okay, so similarly to what we said with the generic APIs, there's two main methods. There's one that allows you to send new data, and one where you're going to send prediction queries, and the code looks like that. So that's an example for product recommendations, where you're defining an app with an ID, first line, and then you record actions. So like when you do product recommendation, you have to record every time a user does something with a product, like adds it to their basket or buys the product. You need to record that. So that's the second line is feeding data to the system. Then the third line is what's that again? That's initiating what they call the engine. So that's where all the machine learning magic is, and you can use engines that are already made for you. You don't have to. You can customize them, but you don't have to. And then you send a query. That's the last line. So you've observed how people interact with products, and you can ask when a new user comes in or when a user comes back, you can ask, which products should I recommend? So the user ID is John, and I want to recommend 5 products, and that's it. So very simple to use, and that's the sort of API that you can create out of the box with Prediction.io. They've got engine templates. For instance, there's an e-commerce recommendation template, and that allows you to reuse the work that someone else has done. Product recommendation is something that's very similar from one company, from one e-commerce site to the other. So why not just reuse the work? And you can also customize it if you want. Do I have 1 minute for use cases? 1 minute, okay. All right. There's, like I said, increasing revenue with recommendations, and actually there's a guy who used Prediction.io and increased revenue by 71%, so that's pretty cool. Reduce attrition, so that was churn. Like I said, you detect who's going to not renew their subscription, so you can do something about it. You can take action. You can also automate decisions with machine learning. So let the data speak and make better decisions than humans using the predictions. Like for instance, you can predict demand, and there's the replenishment use case where you have to. I imagine that you're selling perishable goods, and you have to you have like meat, for instance, and you have to decide how much to ship. And if you ship too much, then the meat that's not going to be sold is going to go bad. So you lose that, and you lose money. If you don't ship enough, then you could have sold more. So you're sort of losing potential revenue. So you need to predict demand so that you can make the right decisions on the business side of things. There's predicting real estate prices. So actually, the interesting thing is that that's where open data really shines, because when you take into account open data about districts, about public transports and so on, and you couple that to the data about real estate properties, then you can predict prices much more accurately. And you can predict crowds. So there's these 2 use cases in France where essentially you want to be able to say how much people are going to be at a train station. SNCF is the train company, and La Poste is I'll let you guess. You predict how many people are going to be at a certain station or at the post office at a certain time, and then you can staff accordingly. Or for the SNCF, the people who use so there's a mobile app, and the people who use it, they know in advance which train they should get on if they don't want to be in a train that's too crowded. And then there's many more examples. So that's Pappies Connect. That's I'm doing a little bit of auto promotion here. That's a conference for decision makers, so people who are not necessarily very technical and they want to learn about these use cases. All of these use cases will be presented. That's in 2 weeks, exactly 2 weeks actually, in Paris on the 21st of May. So if you want to learn more about that, then you know what to do. If you want to find more information about the conference, the URL is pappies.io/connect. And there's a discount code, which is APIdays, and yeah, that gives you, I forgot, 30%, but I think I'm going to bump it up to 40% for a limited time. Yeah. So I'm going to do that right after my talk. Yeah. Thanks to you guys.
We have time for one question. So the presentation was quite complete. Just one thing today, from your knowledge, you know, someone said that technology, really awesome technology, is indistinguishable from magic. Like, I used Google Prediction API for stuff. I say, oh my God, it works. You know, like, it's really like, but I don't know really the model. I really don't know a lot about it. How far you recommend people to know exactly what they are doing using predictive APIs?
Okay, so I think that what's kind of hidden, but yeah, no, it's not. The thing is that when you're doing machine learning, you're sort of making this assumption that, like I said, you want to predict an output based on an input. So you're making the assumption that you know, it's possible to do that. That there's a relationship between the input and the output. So, for instance, I was talking about the real estate example. You know, you want to predict the price of a house based on the characteristics of the house, and you know, the assumption sort of holds true. Like, you know, you would expect that the price of the house would depend on the number of bedrooms, bathroom, surface, on, you know, how close it is to public transports and so on. So it's not capturing all the information. Like, you know, sometimes you sell properties get sold at a higher or lower price because of, you know, some things that you can't capture, like, you know, the person had to sell the house very quickly, or, you know, whatever reason, but you're still able to capture what's going on, to capture the most important things. So the assumption is never 100% true. But, you know, if it sounds reasonable, and, you know, you might have a first try and see, you know, with these input characterizations, do I capture enough to be able to predict the outputs, so for the machine to understand the relationships that exist, because I have domain knowledge, I know that the price of real estate depends on this information. And yeah, I guess that sometimes it doesn't work out, sometimes it does, and you just have to try to see if it works. But there are cases where it's not going to work because you don't have enough characterizations of your inputs, or because you don't have enough examples. Like, for instance, if I only have data about Paris and I want to predict the prices in Barcelona, there are some commonalities, but still, you know, there's some dynamics that are specific to Barcelona. And if I don't have any examples for Barcelona, then I'm not going to be able to refer to those examples to make accurate predictions.
And would you agree that a good model is as good as the data?
Yeah, definitely. And I think that, so I was saying initially, you know, that's this assumption part is sort of hidden, but actually not. I think that with the prediction APIs, you really see it becomes very clear that the model is created from the data. So, you know, if you have bad data, you're going to get a bad model, and vice versa. If you have very good data, then, you know, your model should improve.
And of course, you agree because it's in your book. So yeah, so it's here. A system can only be as good as the data was given.
All right.
So yeah, so this guy is consistent. Thank you, Luis. Thank you very much.